back. Welcome to Cloud and DevOps Batch 55. So before I start the session, I would like to give a quick recap on what's been covered in the previous session. Previous session, we discussed about how networking in organizations looks like is something we discussed. Okay, how in lab we are going to implement and what is the strategy that we are going to follow is something we have extensively discussed, right? Now, in order to implement this approach, we need to have few more things. Okay, so if you are having few more tremendous amount of networks, and if you want to establish communication between two different networks, again, the concept of peering increases based on the number of networks that you have. And at certain point of time, when you think about scalability, it's going to be a mess. Okay, it's going to be a mess. In order to avoid that, what we tend to do is we use another device called as a gateway. A gateway is nothing but a networking device, which is an entry and exit point of the main network. Okay, so let's try to start implementing this network. In order to implement this network, okay, the network that we decided, you need to have some understanding of the networking. You need to have the understanding on the networking. First, I'll ask you one question. How an IP address looks like? Anyone? Anyone? How an IP address looks like?
Hello, Mano.
Yes. How?
Somewhat. Actually, it is a 4-octet number. If it is a
Let's use
IP.
simple terms. Let's use simple terms. No
Uh,
jargons. Let's use simple terms. We'll go there.
okay. Okay. It is a. For example, it is 192.168.20.1.
Exactly. Like x dot y dot z dot p. Right? This is how it looks like. And here, the range of x will be, I assume that you guys don't know and I'm teaching, okay? In case if you guys knew, you need to bear with me for a few more minutes, okay? All right. And the range of x will be anywhere in between 0 to 255. Okay. And y range will also be the same. And again, this Z, you have molecular Z, Z, or whatever it may be. Okay. And this is P. Let's try to use a different color. Done. Okay. This is how an IP address looks. By the way, why we need an IP address? Anyone? Why we need an IP address? Why? Not we. What is the need of IP address? Anyone?
Okay. To communicate over the network, we need a unique address. For example, if I want to post something to your address, we need details, right? Where should you live?
Exactly.
What is
Yes.
the city name?
Yes. IP stands for Internet Protocol, right? A protocol is nothing but set of instructions. If I want to talk to you, since we are all coming from different geographical locations, we all speak different languages. If you want to understand what I am speaking, I need to speak in a language that you understand. That's the reason we use English as a communication in this training, right? That means our common language. That means we are using something which can be understandable by everyone. If a computer wants to talk to another computer, even it also needs some protocol, some instructions, right? So internet protocol is a common protocol that is used by the devices in the internet to establish communication between each other. Okay, that means for each and every machine you will have, okay, for each and every computing machine you will have an IP address, which will be an identity, which will establish it as an identity to communicate to each other in a high level. Okay. Now, okay. That means if a computer wants to talk to another computer, when I say computer, that even includes your mobile phone. Your mobile phone is also a computer. Anything. So in order to establish between communication between the computing devices, you need to have an IP address. You need to have an IP address. But 0 to 255. So what is the world population? 750 plus crores, right? 750 crores is the world's population. Let's assume that way. Okay, it can be plus or minus 10 or 20 crores. World's population 750 plus crores, right? Now, if you take 255, 255, 255, 255, how many IP addresses can we create? For example, you take this figure 256 into 256 into 256 into 256. And if you take this, let's try to bring up my calculator. 256. And if you see this, 424 crores, 49 lakhs, 67,296 IP addresses. Let's try to take it as a 430 crores IP addresses. Now, it is just humans. Let's take companies like Facebook, Google, YouTube, Twitter, IBM, big companies. Even they'll have tremendous amount of servers in their infrastructure, right? Now you take insurance companies, you take retail companies, you take any company, everyone will have hundreds and thousands of servers, hundreds of servers, thousands of servers. Now, if you are able to, okay, if we need to have a unique IP address across the world, unique, okay, the number of IP addresses are not enough and we would have been exhausted, right? And in order to maintain the uniqueness, you need to have a tremendous amount of IP addresses, which is not possible with the calculations that we have. And this type of IP addresses is called as IPv4, by the way. We are having another set of IP addresses as well. That's called as IPv6, which we'll talk about it later. But for now, let's talk about what we know. Okay, so this is called as IPv4. It's called as IPv4. Okay, it's all IPv4. Now, how are we going to maintain it? How are we going to maintain uniqueness across the world? Okay, that's exactly, okay, that created a concept called as, okay, public IP and private IP. So we have two types of IP addresses. In IP addresses, we have two types of IP address types. Let's talk about them in detail. Okay, IP addresses types. We are having two set of IP addresses, two types of IP addresses. One is public IP address. Another is private IP address. Okay, so what is a private IP address? So you join a company, you will have a employee ID which is unique, right? Which is unique across your organization. Other company also can have a similar set of name. For example, if in your company your employee ID is 12345, you join another company, there are high chances, there are even chances the employee ID, number can be the same 12345, right? But in your company, the employee ID 12345 is only to you. Agree? So public IP addresses are like your PAN card or Aadhaar card, which is unique across the world. If your Aadhaar number is 123456, you don't see another Aadhaar number with 123456 allocated to someone, right? So public IP addresses are unique across the world. And if you're having a public IP address, that is won't be allocated to anyone. I mean, same IP you won't be seeing with anyone at a time. Okay. So public IP addresses are unique across the world. and they are not free. Okay, so you need to pay, you need to buy, and you need to reserve it. Okay, and private IP addresses. Private IP addresses are like intranet, unique only within the network. The intranet. Okay, again, in order to maintain the uniqueness across the world, and for example, intranet, internet. Okay, for example, your internet cafes, defense, or the futuristic purpose, and the airways, everyone were allocated certain range of IP addresses. Okay, so before we talk further and more about the public and private IP addresses, let's try to also add few more points. But you need to, at this point of time, you need to understand public IP addresses are unique across the world, and public IP address can be accessed from the internet. If it is a private IP address, that can be accessed only within the network. From the outside, you cannot access it. From the outside the network, you cannot access it. Now, again, further classifying, either it can be public IP address or private IP addresses. Public and private IP addresses, they are classified into classes. Okay, IP addresses are classified based on IP addresses. Classes based on the purpose. Okay, so what is your purpose? For example, you are an airline company. Okay, the pilots needs to talk to the ground station. They use a separate range of IP addresses. Okay, you are into the, for example, you are into the broadcasting company. You use a different set of IP addresses. So how can we determine whether this IP address belongs to this airways, or this IP address belongs to satellite communication? How do they come to know that? And that's why we have something called as a classes in IP address. Let's talk about that. Classes in. Okay, so classes, not WhatsApp, classes in IP address. Okay, so come here and try to take some nice image. Let's try to take this. It has almost all the needed information. Come here and try to paste it here. So this is how it looks like. Okay, so it all starts with the first octet. Okay, so let's try to talk about the public IP address. So class A, class B, class C, class D, class E. Okay, so if your IP address, okay, if your IP address and private IP address, okay, so public IP address and private IP address, they have the classes. And if the first octet starts with 10, okay, if the first number of the IP address starts with 10, that is class A IP address. If the first digit or the first octet of the IP address start with 172, it is called as a class B IP address. And if the IP address starts with 192, that is a class C IP addresses. Technically, 10 series and 172 series are huge IP addresses, huge range of IP addresses. For example, you're starting a company and your company is expected to grow. Right now, you are just 1,000 employees, but you're expected to grow for 2,000, 3,000, 10,000 employees. So keeping the future demands in mind, you need to design the network. Okay, that all starts with designing the network. So technically, 10 series network and 172 series network are pretty big networks. And 192 series networks are local networks, your internet cafe networks, all these things. Okay. So, and also another thing I want to talk, for example, if this is your home network, for example, this is your home network. It's your home network. Home network is nothing but your internet connection to your home network. Now you have a computer, your laptop, and you also have your mobile phone. For example, you are having Alexa, which is connected to the internet. So likewise, for example, you are having 10 devices and everything is connected to the Wi-Fi router. Agree? Here, Wi-Fi router is a device which establishes communication between the internet to your intranet. Okay. Technically, your Wi-Fi device, you know what exactly it is doing? It acts like a gateway between, okay, a router is a device which helps you in establishing communication between outside network to the inside network. Now, do you really think now the internet service provider, ISP, internet service provider, will allocate a public IP address to you because you need to be unique across the world, right? Okay. Now, in order to maintain the uniqueness and in order to maintain the IP addresses availability, you don't need to have a public IP address to this, public IP address to this, and public IP address to this. Your internet router, okay, your internet router is going to form an intranet for you. Okay. So this will be your intranet. Okay. This is your home network. Okay. You can come here and all the devices will be connected to the Wi-Fi router. Okay. Now all of them won't be having a public IP address. Now this Wi-Fi router forms a network. Okay. This gives, if you see your home network, you will have 192 series network. This is unique. May not be unique across the world, but it is unique only within your intranet. That means your father IP address would be 192 dot, I mean, father's mobile or father's computer IP address will be 192 dot xyz dot 190.00.2 and your will be 190.003 and 190.004, and these are not public IP addresses, they are private IP addresses. Whomever you communicate with from your home, it will be this public IP addresses, and that's the reason you should not share your Wi-Fi password to others. The moment you share your Wi-Fi password to others, as per the records, the internet service provider records, okay, this IP address, for example, if this IP address is involved in some anti-social activity, what will happen? Okay, when the trace, okay, that's the request comes from this public IP address, and this public IP address is allocated to this particular guy, and you will be in soup. Okay, so that's the reason the public IP address would be different. And for example, let me open my command prompt. Not fconfig. And if you see this, what is the IP address of it? Come again. And if you see this, it is showing, okay, 10.0.0.98 because I'm using a pretty big router, okay, which gives me almost 1000 plus IP addresses. I'm using a big router, but in your case, generally you see 192 series, which is a home network. Okay, you can give it a try. In your case, it should be 192 series network. All right. Yeah. Sorry. This is Ethernet 192.168.142.1. But this is not my public IP address. This is a IP address that was given to me by my router. By my router. So how do you come to know what is the IP address of yours? What is the public IP? What is my public IP address? Just type it. Okay. It's gonna tell you what is your public IP address. Okay. So that's how it works. Okay. So just by looking at the class, we'll understand whether it is a public IP address or a private IP address. Okay. So public IP address would be unique across the world, and private IP address, for example, you're starting a company. Okay. So for example, you're starting a company and you are expected to have some big network, and your expectation is keeping the future demands in mind. You want, okay, 15,000 IP addresses, for example. Okay. And these 15,000, this is just a draft. Okay. Don't be too serious on it. It's just a draft. Okay. And this in your company, you want 5,000 IP addresses and you're having 3 floors, just in numbers, just numbers. Okay. Okay. Now, for example, in this company named as, okay, Cloud Carriers. Okay. In this company, okay, we need 5,000, 15,000 IP addresses, and first 15,000, I want them on the top of this. Okay, and next 15,000, for example, this, and next 15,000 IP addresses are this. That means you need to form a network of size 15,000 IP address, where this is one network and this is one network and this is one network. Technically, this network is a size of, okay, this network is a size of 15,000 IP addresses, but maintaining one big network is always a big trouble. I'll ask you one thing. There is a big room, okay? In that big room, we have all the software engineers, all the testers, all the analysts, all the scrum masters, and you also have people from Python background, Python developers, QA background, QA developers, and you also have Node.js developers, you also have Java developers. All of them are sitting in a same room. Same room. Now you got a doubt and you want to talk to them. Need to talk to one of the Java developer. None of them are labeled, none of them are separated. If you want to go, you need to go to each and every one and you need to talk, hey, are you the Node.js developer? Hey, are you the Node.js developer? Hey, are you the Node.js developer? You need to ask, right? Because things are not separated. Agree? Now, for example, you want to apply, okay, for example, the same situation, the same room is built in the form of blocks. Okay, one block Java developers, one block or one room Java developers, one room Node.js developers, one room QA, one room Python developers, one room Go developers, and one room AngularJS developer. Now, if you want to talk to anyone in the Node.js developers, what you can do, you can see the room that is having Node.js and you can go them and you can talk to them and get things done. Here, interference, here collision is not there. If you're having a big network, maintaining the network is a challenge. And second thing, if you want to apply policies, it's not possible. For example, your requirement is these guys should have access to internet. Okay, for example, this is first floor, should have access to internet. And these guys should not have access to internet. This is just an example. Now, if you create a single network, if you apply policy to one network, it applies to across the network. Instead, what we do is we cut down the network into pieces. One single network is cut down into pieces. And this process is called as subnetting. And the pieces are referred as subnetwork or subnet. Okay. So in order to define whether it is a subnet, what is the size of the network, how many IP addresses are there in each subnet, okay, you define using some notation called as CIDR notation. CIDR notation. CIDR stands for classless IP domain routing. It's a notation which defines, okay, so 10.0.0/32, okay, 192.168.0.0.32. Okay, it can be a maximum of 32. Okay, now you come here, just say David C calculator, just say CIDR. There is some big calculation, we don't have to go there. Let's focus on the calculator, ready-made solutions that are available. Let's try to see that. For example, how many IP addresses that I want? For example, I just want, okay, 192, I want 10.0.0.0. And if I say 20, okay, I would get how many IP addresses? I would get 4,094 IP address. Now I want 15,000. Okay, so the number can be maximum. In Amazon cloud, you can create a network as big as 16. That means in AWS cloud, you can create a network of maximum of 65,534. Okay, you can also create bigger networks till 8. Okay, but in AWS it's not supported. But in Azure it is supported. In Azure you can create a networks as big as 16 lakh 77,000. Okay, no, 16 lakhs, 70, no, 1 lakh 67,000, no, 1 lakh 67, no, 16 lakh 77,000 IP addresses you can create. Okay, but in AWS you can create a maximum network of 65,000 IP addresses. Okay, now for example, if you say /18, it will be anywhere in between. Maximum value of the slash is 32. Okay, so for example, here it is giving me 16,000, which is close to my network. Okay, now I want to create 4 networks. Okay, you can divide it. Now I want 3 IP addresses. Okay, so maybe this is the network that I got. So first floor, okay, I can mention it as, okay, so come here. This is my overall network range 18. My network range is this /18. Okay, so this determines how big the network is. Okay, so out of this, I want to create 3 networks I created. And this is my first network. I want my reception or ground floor to have higher IP addresses. I have 8190 IP addresses. I'll paste it here. Okay, now next. Okay, this here I'll get 4000 IP addresses. Next. All right, this notation is called as a classless IP domain notation. Okay, guys. Now, this big network we cut down into 3 pieces, and if you want to apply policies, this guy should not talk to internet, and this guy can talk to this, and this network can talk to this but cannot talk to this, and this guy should not have access to the internet, and this network should not have access to the internet, and this network, people who are in this network should have access to internet. All this granularity can be achieved by using this subnetting, and also for the administration purpose also it will be very, very easy. All right. Any questions on this, anyone? Yeah, Sharat, go ahead. You can talk. You can unmute and talk. If you're speaking, I'm not able to hear you, Sharat.
Sorry, Manu, that was long back. I raised it, not nothing else.
All right. Anyone else have any question? All right. Now, what can we do? Okay. So this is a small snippet about networking and how we are going to do that networking. Now, before even we implement this big network, okay, so in order to go ahead and implement this network itself, okay, let's try to understand few more use cases and then we can implement the architecture that we are going to implement, right? So what is the architecture that I want to implement? Let's try to talk about it. Okay, so in lab, this is the network that I would like to implement. Okay, so in lab, this is the network I would like to implement. Okay, but directly going here will be a little tough to understand. So what I would like to do is, okay, initially what I would like to do is I would like to start with this. Okay, this is what I would like to do. So in what I would like to do is I already have a default network. Okay, I already have a default network where your workstation is there. And another important question that in interviews they'll ask you, what are the factors that you will consider before you selecting the VPC CIDR range? Okay, what needs to be considered while selecting the CIDR range? Okay, it's very, very important. Just keep this point in mind. First, what is the size? What is the expected size of the network? Okay, that is very first thing. And second, you need to keep the future demands in mind and you need to design. And you also need to check, okay, ensure your CIDR range, which is nothing but the selected CIDR or the selected IP range is not colliding with the existing network. Okay, so within the network, okay, within the network, no two IP addresses should be unique. So whenever you're selecting the network, okay, that includes both on-prem and cloud. This includes both on-prem and cloud. Okay, so it's not like if you're having connectivity between your on-prem and your cloud, you cannot keep, okay, both of them in the similar range. And if you're having the network similar range, okay, you cannot establish communication and you'll see a lot of challenges. Okay, so before you select itself, these points are something which needs to be keep in mind. All right. Any other questions?
Hi, Manu.
Yeah, Ravi, hi.
Yes, Manu. So in that IP,
I
we
can,
have
your voice is
covered.
feeble. Can you speak a little loud, Ravi?
Okay. You can hear me now?
Yes, perfect, loud and clear.
Yes, Manu. So in that IP, we are providing some standard
Mm-hmm.
x.x 19 r slash 12
Mm-hmm.
something we are writing, right?
Mm-hmm.
So what is that slash 12 or slash 19?
It's a size of the network. Okay, it's a size of the network. Come here, it determines the size of the network, and this value can be a maximum as large as 32, while 32 gives you one IP address, and lesser the number, higher the size. Okay.
Okay.
And if you really want to know why slash 32, why is 256, there's a big story behind that. And if you're interested, I can also tell that. Okay. I think if this is a question, you should also ask another question. Who told you it is 256 when we are talking about the range? You got this question, by the way?
I have a query, but I didn't ask you.
Yeah, that's a valid question. Yeah, let's try to take this as well. So why the IP address is 256? Why not 250? Why not 1000? Right? We are discussing about the octet range is 0 to 255, which means it will be maximum of 256, right? If you take A.B.C.D, okay, A can be maximum 0 to 255. That means it is 256 IP only. B can be 0 to 256, 255. That means 256. C is 0 to 255. That means 256. Why only 256? Okay, so that's where the concept of octet comes up into picture. Okay, let's take. Okay, it takes little time, but that's fine. Let's take it. Okay, so this is an IP address. Copy this. Okay, this is how it looks like, and it is called as an octet. Okay, IP addresses are designed keeping the octet structure in mind. Octet is nothing but 8. Okay, so this is, okay, each and every number, okay, 8 bits. 8 bits, how many bits we have? 8 bits. Okay, what is a bit? Bit is nothing but 0 or 1. Computer only understands either 0 or 1. Either 0 or 1. That means here the probability is either 0 or 1, right? Either it is 0 or 1, right? Either is 0 or 1, 0 or 1, 0 or 1, 0 or 1. Likewise and like forth, right? So here, if you take a list, okay, the number of octet, okay, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, and 7. Okay, and if you take 2 power 0, okay, you have two values, 0. 2 power 0. What is the 2 power 0 value, guys? Anything power 0 is? Anyone? Anything to power 0, 2 power 0, 3 power 0. Anyone?
1.
Exactly. Anything to the power is 1. Anything power to the 0 is 1. So what is 2 power 1? Satish, you're strong at maths. Come on, go ahead.
2.
Okay. 2 power 3?
8.
2 power 2, 4. And 2 power 3 is 8. And 2 power 4, 16. Okay. 2 power 0, 1. 2 power 1, 2. 2 power 2, 4. 2 power 3, 8. 2 power 4, 8 to 16. Then this is 32. And this is 64. And this is 128. Okay, so if you take a count 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64, it will be 256. And that's the reason the range is 256. Same for all these things. When you say, okay, for example, when you say if the network range is 10.0.0.0/16, okay, when you say this as a range, that means first 16 bits are already occupied. That means, okay, first 16 bits, okay, that means here this is occupied. You cannot use it. That means it's already failed. And these are already filled. Okay, that means you have 8 more bits and 8 more bits. Okay, that means here you get 256 and here you get 256 and 256 is 64,000 IP addresses. All right, is it clear? Ravi?
Yes, ma'am.
I'm not able to hear you, Ravi.
Yes, ma'am.
Okay, perfect. Now, what I'm going to do is directly implementing the big network is the lab is a quite challenging. What I would like to do is, okay, I would like to do is, this is what I would like to do. This is the default VPC. And let me try to, okay, now I would like to create 2 networks. Okay, this is my lab network, for example, for the purpose of lab. Okay, so I'll create a lab VPC. Okay, I'm going to create another VPC that's called as a lab VPC. Okay, and I'm going to create some network. Okay, so here, what I would like to do is I would like to create 2 networks. Okay, 2 subnets. This will be a big network, and I would like to cut that into 2 pieces. Okay, so 2 networks I would like, 2 subnets I would like to create. One is public network and another is private network. So public network, let me try to put it in green color. That means it can be accessible from the internet. And private network I would like to represent in red, which means it cannot be accessed from the internet. Okay, let me try to add in right color. Okay, so this is a public network and this is a private network. This is my public subnet. This will be my private subnet. Okay, now what is a public subnet and what is a private subnet? Anyone? Okay, so first thing, okay, so what is public subnet? Okay, all the machines that are launched in this network, in this subnet, will have a public IP address. This point is very, very clear. Okay, and second thing, this network will have, this subnet will have access to the internet. Okay, and machines in this subnet can be accessible from the internet. Keep this point in mind. Okay, in our case, okay, only the front end component will be in the public subnet, and rest of the machines like your Redis, MongoDB, catalog, cart, shipping, everything should be in the private subnet because they should not be exposed to the internet. Then what is this private subnet? Let's talk about it. Okay, all the machines that are launched in the subnet will only have private IP address. Okay, so all the machines that are launched in the subnet will only have a private IP address. Okay, the subnet, okay, will not have access to the internet. Okay, that means machines that are machines in the subnet cannot be accessible from the internet directly. That is one important point. And if you want to access any of the machines in this network, for example, if you are having your corporate infrastructure here, okay, for example, these you are having two servers, two payment servers. Okay, for example, this is some payment app. Okay, this is a payment server, and this is a payment server. And if these are application servers, and if they want to talk, if you want to talk any of these machines from the internet, direct access is not there. So what we do is we'll use some workstation, okay, or a jump host. If anyone wants to SSH to any of these machines, first we want to connect to this machine. That means we need to do a SSH, okay, to this machine, and from this machine we need to SSH to any of these machines. Okay, direct access from the internet we are going to restrict. All right, is it clear, guys? Okay, now let's try to see that. Okay, so these are two important points that I want to add. Now this is what I would like to implement. Okay, now I also want to ensure, okay, I have a default VPC and my workstation, Jenkins, everything are here, right? In this network, in this public network. Okay, this is my Nexus, all the project machines. Okay, so all these machines, okay, this is my Nexus machine, which are in the default network. And this is my Jenkins machine. Both of them belong to the same project, but are in the different network. That's it. Okay. And this is my workstation. Okay, and this, let's try to add this internet as well. It's the internet. Okay, and if these machines wants to SSH to any of the machines, it has to go here and from here to here. Okay, that means just for the visual representation, we used just as internet as one hop. But if something goes to internet, you'll have phenomenal amount of hops. Okay, then it has to pass through different networks. Okay, let's try to see that. Okay, so first, as a part of the architecture design, if you want to create a VPC, you need to have a range. Okay, so for the purpose of the lab, I would just need, okay, so first, whether I need to select 10 series network or 172 series network is a question, right? You come here and look at the VPC, okay, in your account. Okay, in my account, I only have one VPC, and the scope of the VPC is region. If you create a VPC in Amazon, in VPC stands for Virtual Private Cloud, which is a network as a service in Amazon. Okay, so the scope of the network is regional. If it is Google, the scope of the VPC is global. Okay, so we are in the North Virginia. If you create a network in North Virginia, and if you search in France, it will not work out. And here the network series is 172.31.0.0. So you need to select something which is not like this. Okay, so which is not the same. So in my case, I would like to select some 24. Okay, 10 series 24, which means I would get around 254 IP address. Okay, it's a big range. Just for the demo purpose, I would like to go with 10.0.0.24. Come here and I would like to mention it. This is the CIDR. Okay, 10.0.0.24. Okay, now I want to create two networks out of it. Okay, so overall this gives me 254. Now I want to break it into pieces. Okay, and if you go with 10.0.0.25, it gives you 136 IP addresses, and if you go with 10.0.0.128/25, it gives you 126. So this is a CIDR notation of one network. Okay, guys. So this is what I want to implement. Any questions on this, anyone so far?
Manoj, one small doubt. Normally, when we use 24 in a class C, right, we'll get 192 start like that, right? Normally in classful IPs. We are using 10 dot series, and the sense also I'm not getting and understanding this part. Can you please tell me?
We are going with classless, not classful. CIDR, all the cloud providers, everyone follows classless IPs, not classful.
Okay.
Okay.
Okay. In the sense, we based on the series, we are not we are not judging. I'm not sure how to ask this, but I'm getting little.
Can you draft your question? I didn't understand your question, to be honest. Can you please re-ask your question?
That's why what I got confused is normally when we use 24, right, it will start with 192. How we are using in 10 dot series? That is my
No,
confusion.
that's
That's all.
not true. That's not true. Okay, so you're talking about private IP range, right?
Yeah. Normally we'll use like that, right?
No. Let's talk in the internet. Okay, can you see this? If you want to go with class A, it's 10 series, 10.0 series, and all the way to 10.255.255.255. And if you want to go with class B, it's 172.16, starting with this, and ends with 170.31.255.255. You can choose any network in between this range.
Okay.
Okay. I mean, you don't have to take my words. You can take internet response, right? Agree?
Yeah. Okay. Yeah. Sure.
Yeah. And network, it's globally unique. Okay, there are no two answers for it. It's one answer. Everyone follows that. That's a protocol. Okay. Is it clear?
Yeah. Got it.
Perfect. So how can we do this? Okay, so first we know that our network is this, so we got all the ranges and we allocated the range as well. Okay, so this is the 10 series network, and this is 10 series network and 172 series network. Let's try to do that. So first you need to create a VPC. Okay, so let's go ahead and create a VPC. And I would like to say VPC only. Okay, there is some advanced mechanism as well. You can mention, okay, how many subnets you want, what is the range, okay, so how many availability zones that you want to create, how many public you want, what is private you want. You can mention in everything and create it with a single click of a button. You get everything. But let's turn the manual way so that you learn more. Okay, so I would like to name it as a lab. And what is the range of your VPC is what it is asking. You can come here and copy and place it here, and this is the range of my network. Okay, so tenancy, just go with the default, whether you want to go with the dedicated devices or default. Okay, so whenever you are creating dedicated host is nothing but the host where it is allocated to you, where all the virtual machines that are running on that host will only be belonging to the same client. Okay, in order to do that, you need to create a dedicated network. Okay, but that's not my interest, so that's fine. Simple and straight. Come here, because there are certain applications which runs only on the bare metal servers because of the licensing demands. So in that case, we go with the bare metal servers or dedicated hosts. Okay, I got my network. As per this diagram, once the network is created, what is the next step? Anyone? As per this diagram, as per this architecture, what's the next step?
Creating virtual machine.
So Prem, I could see your message unable to join. It's showing 8 AM. Where is it showing? Prem?
Yeah, Manu. Hello. Yeah,
Yeah.
yesterday fully it was showing for me 8 a.m. meeting only. So I thought, okay, meeting has been not been started. But later on, I came to know that already the yesterday's session was taken, and today
I
also it was showing 8 a.m. session.
where it is showing?
Whenever I joined open that link, the
I
meeting
don't
link.
think so. Ensure you, but yeah, that's fine. Yeah, share. Think that Google Doc is a source of truth. Join 7:30 to 9 are the timings. If there are any deviation, we'll notify you. Okay. But yeah,
Okay.
all right. So in order to achieve this, we need to create the subnets. We have the network VPC, and then we need to create two subnets. The first subnet is public subnet, whose range is this, and another subnet is private subnet, whose range is this. Let's try to create it. Okay. It's always recommended to add the VPC name as a prefix so that you'll understand this belongs to this. Okay, so create subnets. and under which VPC you want to create the subnets. I would like to create the VPCs for this particular VPC, labs VPC. Come here. I would like to create a public subnet. And which availability zone you want to create. Okay, technically when you are creating the infrastructure, we'll choose two different zones. Okay, zone 1A and zone 1B, so that your infrastructure will spread across two different geographical locations, so that this will play a very important role in defining the fault tolerant infrastructure or to handle the disaster events. Okay, it's called as a high availability, by the way. Okay, so yeah, so I want to choose zone 1A for public and zone 1B for private. Come here and try to choose that. Or you can also mention I don't care, which means no preference. So here, but we are going with the design oriented approach. Come here and mention this. Okay, name, done. Come here, create subnet. Okay, lab. And this time I would like to choose this. Subnet name is lab icon. Okay, and availability zone is east 1B, and copy this. That's all. Okay, now you have two VPCs and two subnets. Okay, and you can also check here, and this subnet ID is this, and it is in US East 1B, and it is in this particular VPC. That information also you can see. Can you see this? And when you select it, says it belongs to the lab VPC. All right. Or if you want to add this piece of information also, you can add that. Okay, yeah, it's already added. Yeah, can you see this? It belongs to the lab VPC. Now, what's next? Okay, now let me try to launch a machine in this network. Now, all these days, when you're launching a machine, directly it is coming in the default VPC, right? Now, I'll try to launch the machine and will prove where it is going to create. Come here, I would like to launch a machine. So go to the EC2 service. Okay, now I would like to launch an instance. Okay, launch the instance. Okay, I would like to name it as a public server, a lab public server. I'm just following the proper naming standard. Okay, I'm just choosing one AMI. In my case, I have my own AMI, CentOS 7 Linux 123. Scroll down. I would say proceed without a key pair. And here I'll choose the network as, okay, here I will choose the network as a lab VPC. All these days, by default, it is choosing default. Now today I'm choosing the lab VPC. And here, why auto assign public IP is disabled. If you are launching a machine, as per the theory that we understood, if you launch a machine here, it should have a public IP or not. Anyone? Whether it should be having a public IP or not. Anyone? Anyone?
It should
Anyone?
have public.
Exactly. Yes, it should have a public IP address, but why it is not coming up by default? Why it is asking me, do you want it or not? Why do I need to select this way? No, 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 no. So that property by default, when you create a subnet, okay, by default, when you create a subnet, it won't give you the option. You need to enable that option. So select the lab public subnet. You have an option here, edit the subnet settings. Click on this and click on enable auto assign public IP address. The moment you do that, the machines that are created in this particular subnet will have the public IP address. Now let's give a try again, one more round. Launch the instance. Okay, I would like to name it as lab public server. My AMIs. I just have CentOS 7 Learning AMI. Select the CentOS 7 Linux Learning AMI, and I would like to proceed without a key pair while it's loading. Yeah, key pair, proceed without a key pair. And in the network settings, choose the lab VPC. And here I would like to launch the instance in a lab public subnet. And another important point, very important point, scope. Okay, scope, which is nothing but visibility. If you create a security group SG B55, okay, security group B55 in the default VPC, don't think that is available in this other VPC as well. No, the scope of the security group, the scope of these are, okay, the scope of these are with respect to the VPC. If you create something within the VPC, that is available only within the VPC. Okay, keep this point in mind. Now I would like to create a security group, naming it as, okay, so lab security group, lab public security group. Okay, lab public security group. And here I would like to say I would like to allow port number 22 anywhere from the internet. That's all. And that's it. Let's try to launch my machine. Now my machine should be launched. Let's try to see whether it launched or not. It's getting launched. Let it launch. Now the VM is launched. Okay, it's in the pending state. That means the resources are not yet allocated to this. Let's wait for it. Okay, now the status of it is in the pending state. That means the resources are not yet allocated because I think I have chosen T2 micro. So always even when there are high capacity demands, okay, so it will be given some lesser priority. I would like to wait for a minute, or meanwhile I also want to launch one more instance with the T3 micro. So let's wait. Proceed without a key pair. Security group. Select the security group. I already have a security group, lab security group. Okay, I would like to create a security group. Select the subnet as lab subnet first thing, and then select the lab public subnet, and then select the security group. I already have created a security group, lab security group. That's all. Launch it. Now I'm not creating a free tier instance. I assume it should be coming up. Yeah, both of them are running. Okay, wonderful. So yeah, I don't need it. Just take it off. One is enough. Yeah. All right. Now you come here. Okay, now the machine is up. Let's try to connect and see whether it is having an IP address or not. Says it has a public IP address since we have launched it in the public network. Copy this, you come here and try to connect. Open your Excel, try to connect. Why I'm not able to connect? Why? Why? So guys, in your home, at your home, if you establish a connection to the internet, what is the first thing that your internet service provider does? Anyone? Satish,
They
if you
will
take an
assign the
internet
IP.
connection at home internet, what is the first thing the internet service provider does? They'll come and fix a router, right?
Yeah.
They'll fix a modem router, a modem plus router. So a router is a device, okay, which establishes communication between external network, or it's a in a nutshell we can say router is a device which helps in establishing communication between two different networks, right? Now, in the AWS space, we call them as a IGW, Internet Gateway. In order to establish communication to the internet, you need to have an Internet Gateway. Okay, so you need to create a Internet Gateway object, and then we need to add it to this particular gateway. Then external requests can talk. So technically, none of them can directly reach. It should come to this place. Okay, this is how it will be. Okay, you need to attach an internet gateway now. Okay, and another thing, you can create internet gateway one per VPC. You cannot have n number of gateways per n number of VPCs. Okay, you cannot have n number of gateways, internet gateways to single VPC. Okay, one VPC can have only one internet gateway. So you come here and try to create. Okay, so come here. Where is the gateway? Internet gateway. Come in the VPC, create an internet gateway. I would like to say lab hyphen IGW. Okay, come here and try to create an internet gateway. Okay, you can come here and you need to attach it. Okay, you created it, you attach it. Which network you want to add? I want to add it to the AWS Lab VPC. Attach it. Attach it. Now it's attached. Now let's try to access it. Okay, the connection is failed earlier. Let's try to connect. Let's see what will happen. Let's see what it's gonna report. All right, connection is failed. It's not timeout. Connection is failed. Timeout is nothing but connection is there, but firewalls are restricting. Okay, so connection failed. And if you see connection refused, that means the request is going to server and server is denying it. Connection failed. There is no path itself. I'll tell you why. I'll tell you why. You establish the connection, okay, from if you have an internet gateway that acts like an entry point. But once the request comes here, how it comes to know it has to go here? How it comes to know? How it comes to? No, guys, you got it. Now, in order to establish the communication, okay, you need to use something called as the route. Okay, you need to define a route. Okay, and the requests are coming from the router, that is nothing but from the internet. Okay, ensure you forward the request to this. Okay, that means each and every subnet will have something called as a route table. Okay, so you have something called as a route table. you need to have a route table. It's a route table. Okay, you need to have a route table. And again, this route table, how public network should behave, how private network should behave is also something we define the route. Okay, route is defined with a path. Okay, public route table. Okay, you can have one route table per subnet. Okay, you are not going to create route tables for virtual machines. You are going to create a route table for the subnet. Keep this point in mind. Okay, now you need to create a route table and then you need to attach it to the public subnet. Let's try to see that. What is a route table? Let's see that in detail. Okay, you need to define the route. Okay, so create a route table. Now you need to mention that we are going to create a route table. Okay, lab public. If you see, I'm following the VPC name as a standard. Okay, lab public subnet route table, and I would like to create this inside this. Now create a route table. Now once the route table is created, you need to add it. Where you need to add it? I would like to add it to the public subnet. Okay, so add it and add it to the public subnet. Now you created a route table and added it. Right now you can come here, and if you see this, if you want to talk to any of the machines in this network, this can talk over the local network. Okay, but there is no route defined if requests are coming from external network. Okay, now edit the route, add a route. I want to say if any of the requests that are coming from the internet 000/0, that means internet. I would like to mention, I would like to go with the internet gateway, and the name of the internet gateway is lab IGW. Okay, so you created a route. That means you are telling your subnet route. Okay, if any of the requests are reaching the internet gateway, hey, reach me. That means you are establishing a route. And if you come here and try to see this, now it will establish a connection. Now the password is password 123. Perfect. Now you are connected. Can you see this? And you are in the 10 series network 10.0.0.69. Can you see this? Okay, now let's try to see whether it has access to the internet or not. Ping google.com. Obviously, you'll have access to the internet. This machine is having access to the internet. Okay, set. Okay, so if you see this, this is my public machine, which is in the 10 series network 10.0.69, which is a public machine. It's fine. What's next? Okay, echo. All right, any other questions, anyone? Just a second. Okay, whatever it may be. If you see this, this is the public server. Now I would like to launch another server in the private network. Okay, let's try to see. Now go to the launch an instance. You can come here. Again, try to launch a network. Lab private server. Okay, now you need to mention the AMI. Come here and try to mention the AMI and CentOS 7 Linux Learning AMI. Select this. And I would like to choose it as a T3.micro. Come here and keep it as proceed without a key pair and network. And here I would like to choose the lab network. And this time I would like to launch the machine in the private network. Okay, and if you see this, okay, if you select the public network, okay, by default the auto assign public IP is yes. And if you by default, if you select the private network, okay, it will be disabled. Okay, now I would like to create a security group, or just go with the security group that is already there. Okay, so come here, and that's all. Launch the machine. Launch the machine. Okay, so the instance is launched. Now I would like to name this instance as lab private server. Let it come up. Okay, now it is in the running state. And if you click this, you will not be having private IP address. See, in organizations, 99.99% of the times, none of the machines will be having public IP addresses. And if you cut down the public IP addresses, 99% of the problems would be solved. Okay. All right. Now let's try to see whether we are able to connect to this machine or not. Okay, you can come here and SSH. Okay, since it doesn't have any public IP, you cannot connect from the external network. That's for sure. SSH. Okay. Okay. Echo. Split the network. This is the public server. SSH2. Okay, this is a private server, and this private server won't be having any public IP, so it cannot be accessed from the internet. And if you try to check whether it has access to the internet or not, it won't be having access. But the same machine, if you try to check ping google.com, it will have access to the internet. Now, how are we going to handle it? Now, if it doesn't have access to the internet, that's fine. But what if this machine wants to do patching? What if this machine wants to install any patches? So that's the reason how we need to design the network is, okay, if these machines wants to talk, they should be able to talk. That means communication from outside to inside should be disabled. But if the machine wants to talk, that means from inside to the outside, it should be enabled. Okay. All right, guys. So the communication from outside to inside should be disabled. But if the machine wants to talk to the internet, it should be able to talk. Okay. So, but it's not going to be done directly. Okay, so in order to establish, okay, this is what we want to do. Okay, so communication access to private machines from the internet should be disabled. Okay, but access to internet from the machines should be enabled. Okay, how can we do that is something we'll see in tomorrow's session. Okay, so yeah, that's it. Any questions, guys? Any questions? Okay, so I raised the challenge, right? This machine, if this machine wants to do patching, yes, it can do. But if this machine wants to do patching, it is not having access to internet. And in organizations, it's not 1, 2, thousands of machines you'll have. Okay, if you cut down the internet, you'll be landing into a big problem. So we need to do it in a more mature way. How to do that is something we'll see it in tomorrow's session. That's for today. Any questions, anyone? Okay, what I'm gonna do is I'll just turn off all the machines and we'll resume tomorrow. Okay, and yeah, that's it. That's for today. And any questions, anyone? So Satish, when is Ganesh Chaturthi? You mentioned again. It's celebrated on 18th.
Monday.
I mean
Yeah,
August, Monday or Tuesday?
Monday.
Monday it is celebrated.
Yeah.
Okay. If that's the case, let's have a session tomorrow, guys. Okay. Monday I'll declare a holiday. Okay. Monday will declare a holiday. Let's have a session tomorrow, Sunday. Okay. I'll keep it updated. Thank you, guys. Yeah, come on, go ahead.
Hi, Manoj. Difference between security group and route table.
Security group is like a firewall. Route is a path. Okay. I want to tell you, you go to the Manyata Tech Park and go to this XYZ block. I'm telling you the path, route.
Okay.
Once you go to the office, whether you need to be allowed into the block or not is based on the access that is defined on the access card. Okay, your access card and the rules that are defined in your company is a security group, firewall. Okay, route, path. Any questions, anyone, guys? All right, and that's for today. And see you tomorrow. Signing off for the day, guys. Bye.